Coal. Over millions of years, terrestrial and marine plants and animals become buried under sediment, rock, ash, and mud. Heat, a lack of oxygen, and tremendous pressure combine to chemically change the carbon-rich organic matter into a mixture of compounds we call fossil fuels. Coal is the most plentiful of fossil fuels on the planet. Like petroleum and natural gas, coal releases tremendous amounts of heat when burned. If energy was the only consideration, fossil fuels would be a nearly ideal energy source. They are transportable, storable, and energy-dense. Almost all aspects of human society are now tied to the use of fossil fuels in some way, including electrical generation. 22% of all electricity in Canada and almost 70% of the electricity used in the United States is generated by burning fossil fuels. Here in New Brunswick, the Belledune coal-fired thermal generating station above Bathurst, with a capacity of 490 megawatts, accounts for around 20% of the province's electricity. The plant is now a little over 20 years old and is run by a staff of 50. Coal has two serious disadvantages shared by other fossil fuels. First, it is a non-renewable resource. Although there are ample coal supplies presently, these are diminishing. Second, and most sobering, is the recognition that the burning of all fossil fuels releases toxins and greenhouse gases into the environment. Greenhouse gases contribute directly to climate change through the greenhouse effect by trapping heat inside the atmosphere. The mining of coal also has negative consequences on the environment and human health. There is no easy solution, yet. Let's look at the pros and cons of coal and see how utilities are working to maximize its benefits and minimize its harmful effects. Coal is brought to Belledune's port on the Bay of Chaleur by cargo ship from around the world. This ship unloads the coal by conveyor belt. For other ships, the Continuous Ship Unloader, or CSU, is used to unload more than 2 million kilograms of coal every hour. The coal goes on a system of conveyor belts that are over 3 kilometers in length. The conveyor belts move the coal to storage facilities until it is needed in the plant. Several different grades of coal are delivered to Belledune. These different coals are combined for their chemical properties to produce the best heat at a reasonable price. High-grade coal comes from Colombia and is stored in the huge coal house. The coal house can hold 120,000 tons of coal, or enough to run the generating station for 30 days. 10 times that amount of cheaper, lower-grade coal from the western U.S. can be stored in the coal yard. Petroleum coke, a byproduct from refining oil, comes from the Great Lakes region and is stored in the coal yard. Belledune coal first needs to be crushed into a fine dust before it can be burned. This job is done by 5 separate pulverizers. The fine coal dust now makes its way to the boiler, which is the heart of every thermal plant. The boiler is a 12-story tall furnace suspended from the roof. The crushed coal dust is mixed with air and injected into the boiler, where it burns to produce air temperatures of over 2,000 degrees Celsius. That's easily hot enough to melt iron. Now to make steam. Water that is superheated has to be very pure, or it will quickly corrode the pipes of this closed-loop system. Fresh water is demineralized and purified right in the Belledune facility. Then it is piped under pressure through the intense heat of the boiler. The result is high-pressure steam at 540 degrees Celsius. The energy from coal is now energy in pressurized steam. This next part should look familiar. The high-pressure steam is forced through the turbine blades, causing them to rotate and spin the generator at 3,600 RPM. The Belledune thermal plant has produced electricity. All thermal generating stations, like Belledune, deal with the transfer of energy. The thermal energy from burning coal is turned into mechanical energy or work by heating water to steam and using the pressure of the steam to spin the turbine. The generator transfers the mechanical energy to electrical energy. Largely due to heat loss, this process is about 33% efficient. That means that only about 33% of the energy in the coal is converted directly into electricity. Throughout the day, Belledune receives instructions from the system operator as to how much electricity to produce. The demand for electricity will vary according to the time of year, the time of day, the weather forecast, and how much power is being generated at other stations throughout New Brunswick. Belledune operates at 80% capacity on average annually, with some in reserve for special needs. This steady supply makes Belledune a baseload station. It is very reliable during New Brunswick's cold winters and as a supplier to heavy industry. Belledune can go from minimum running capacity to full capacity in about 2 hours. There are other fossil fuel plants in New Brunswick which are designed to meet rapid spikes in power demand. They're called peaking stations. A typical demand peak occurs on especially cold winter days when extra heat is needed. Few other fuel sources can respond so quickly and predictably as fossil fuels. Let's examine the technology used to lower waste and increase efficiency. After the steam passes through the turbine, it needs to be cooled back down to a liquid state. This happens in the condenser, where the steam pipes pass through cold ocean water. Belledune draws over 10,000 liters of cold water every second from the Bay of Chaleur to perform this heat transfer. The greater the cooling, the more efficiently the entire system works. This warms the seawater by about 10 degrees Celsius before it is sent back out into the bay. The flue gas leaving the boiler is still very hot. Rather than waste this energy, the residual heat is used in many ways throughout the plant, from pre-warming air to reducing nitrogen oxide emissions. This is a cost saving and helps increase the station's efficiency. What about reducing emissions? When coal is burned, it reacts with elements in the air and creates flue gas. Flue gas contains oxygen, nitrogen, and a lot of moisture, but also carbon dioxide, ash, and trace minerals. This needs to be cleaned up before it is released into the air. The first step in purifying flue gas involves removing the particles of ash. There is a fine dust called fly ash and a coarse dust called bottom ash. Because bottom ash is heavy, it falls to the bottom of the boiler. It is removed by conveyor belt and trucked to the landfill. Belledune produces 35,000 tons of bottom ash annually. That's as much weight as 100 Boeing 747s. Fly ash is removed from flue gas in a device called the electrostatic precipitator. Fly ash particles are electrically charged and stick to metal plates, just like static electricity makes your hair stand up straight. From there, it can be knocked loose and collected. Fly ash is an important component in the making of Portland cement. Over 99% of the fly ash is collected in this way and sold. It is not released into the air or sent to a landfill. And the recycled ash reduces the need for new raw materials that would have to be mined from the earth. That accounts for the ash. Now flue gas moves to the FGD, or flue gas desulfurization unit. Coal contains small amounts of sulfur. Cheap, low-grade coal has more sulfur than expensive, high-grade coal. When coal is burned in the boiler, the sulfur combines with oxygen to form sulfur oxides. Sulfur oxides are the cause of acid rain. Since 1993, the law requires that generating stations remove 90% of the sulfur oxides from flue gas. This is done with the help of limestone. Limestone is ground into a powder and mixed with water to create what is called slurry. As the flue gas rises up the FGD, slurry is sprayed down from the top. Limestone in the slurry chemically reacts with the sulfur oxides in the flue gas, producing gypsum, the major component of gyprock or drywall board used in home construction. The gypsum is collected and is sent by train to centers like Montreal to drywall plants. Belledune was the first electrical generating plant in Canada to install an FGD unit. At this point, the flue gas is mostly oxygen, nitrogen, carbon dioxide, and water vapor. Oxygen and nitrogen are harmless gases, but carbon dioxide is a greenhouse gas responsible for global warming. Between 2.5 and 3.7 megatons of carbon dioxide are released by Belledune Generating Station every year. That's about the same amount of carbon dioxide emitted in a year by 600,000 cars. At this time, there is no economically feasible way to remove the carbon dioxide from the flue gas, and it is not required by law. Carbon capture technology is still developing. The flue gas is released into the air by passing it through a 168-meter tall stack. The white plume coming out of the stack is actually just water vapor. The other gases are invisible. Coal is an important source of electrical generation for New Brunswick. It is reliable, inexpensive, and can respond to changes in demand. More coal can be burned if demand increases. Technologies have developed to increase efficiency and reduce the release of pollutants into the environment. But perhaps the biggest environmental challenge that faces the planet today is global warming and climate change. Carbon dioxide is a chief contributor to the problem. Now that you've seen how a coal-fired generating station works, how do you think New Brunswick can overcome this seeming impasse?